Hey guys, this is Miss Garner, and this video will go over the beginning of solving Pythagorean theorem word problems. So this first slide is a quick review. You will see on the left-hand side we have this triangle. They've given us two sides. And the first question is asking, are we solving for the hypotenuse or a leg? So just a reminder, if you go from your right angle and you draw those two arrows out, those are your two legs. So we can see that the 4 and 8 are legs. So that means we are solving for the hypotenuse. Our next question is just asking about our steps in order to solve. So after squaring each of those numbers, are you going to add or subtract? And when you're solving for your hypotenuse, you are going to add. Okay, so you would do 4 squared plus 8 squared. So remember, our Pythagorean theorem is a squared plus b squared equals c squared. Okay, so that's that first problem. The second problem over to the right, once again, we are given two sides of our triangle. You will notice at this time, though, if we do the two arrows from our right angle, we are given one leg, but the other leg you see here is missing. That 13.3, that is the hypotenuse. So in this case, we are going to be solving for a missing leg. And the next step, it says after squaring each number, what are you going to do? And because we're solving for the leg, we are going to subtract. So all the other steps are identical. So you're still going to square both those numbers. Your last step is still to take the square root, but remember, instead of adding, you're going to subtract. And the reason for this is, remember, we're going to rearrange our formula and do hypotenuse squared minus the leg that we have squared, and that's going to give us the remaining leg squared. Okay, so remember, when you are solving for the missing side of a right triangle, you need to figure out whether you're solving for the hypotenuse or the leg, because that will determine whether you're going to add or subtract. Moving on, for our notes for word problems, these word problems are going to mirror real life situations where you might use the Pythagorean theorem to answer some question. So the first thing we're going to want to do is read the problem, and we're going to underline important information. So just like in your English classes, when you annotate the text, with these word problems, we also want you to underline. In our case, with math, that usually means the numbers. Which numbers are we going to be using from that word problem? The second thing is you want to draw the picture. So this picture will help you understand what this problem is asking and how you're going to solve it. Remember, because we're using the Pythagorean theorem, your picture should somehow have a right triangle in it. Okay, so we know if we're going to use the Pythagorean theorem, we're going to have a right triangle somewhere. The third and fourth is what we just talked about. So we're going to determine if we're solving for the hypotenuse, in which case we're going to add the two numbers after squaring, or a leg, in which we're going to subtract, and then you're going to solve. Okay, so that's what we just talked about. That's what we've been doing for several weeks now. So steps 3 and 4, you should be used to. And then the fifth one is just going to be restating the answer in terms of the word problem. So for instance, if the word problem is asking how far away you are from town, you might answer you're 5 miles from town, right? Your answer is not just going to be 5. You want to put it back in terms of what the problem is actually asking you. So those are our steps for our word problems. We will go over 2 examples. So this first example, I'm going to go ahead and highlight the information that's important. So Tom is afraid of heights above 9 feet. Okay, so that's important. We've got a number here. So anything above 9 feet, Tom is afraid of those heights. He is asked to repair the roof of his house. The bottom of the ladder must be placed 6 feet from the house. Okay, so once again, that's important. You've got a number involved. The ladder is 10 feet long. Okay, and then the questions I like to underline in green. So the 2 questions we're being asked are, how far above the ground does the ladder touch the roof? And then, is Tom afraid of the height? Okay, so Tom, he's kind of afraid of heights. He needs to figure out, is the roof at a height so that he's able to make those repairs, or is it too tall and should he call a friend to come help him? Okay, so that's the situation we have going on. So we've underlined, we've read our problem. We're going to draw our picture now. So these pictures don't have to be fancy. but they should show what is going on in the problem. So here is our house with our roof, and we know we have a ladder leaning against it. That ladder is going to go up to the roof so that they can make repairs. Okay, so here's my ladder. It's leaning up against the house. And just a reminder, since we're doing Pythagorean theorem, we know to be on the lookout for right triangles. Hopefully you can already see in this problem that a triangle here has formed. Okay, so I'm going to put in blue where I see that triangle. So if you look at this side of the house, the ladder leaning up against it, and then also the ground, you can see that we have that right triangle there. Okay, so there's our picture. That's our situation. What we want to do is we want to label that picture with our numbers. So if we go through the text, Tom is afraid of heights above 9 feet. That's not telling me anything about my picture, right? It's not saying the house is 9 feet, the ladder's 9 feet. That's just about Tom, so we can ignore that part for now. The next is the bottom of the ladder must be placed 6 feet from the house. Okay, well, here's the bottom of the ladder. I just put a red star there. It must be 6 feet away from the house. So this bottom side there has to be 6. The next piece of information we have is that the ladder is 10 feet long. So this whole length here, that diagonal where the ladder is, I know that that is 10 feet. That means the side that I'm missing is this one that's on the house. And that's exactly what it's asking for. How far above the ground does the ladder touch the roof? So I'm trying to find this right here. All right, what is this distance? How far up does that ladder go on my house? You'll notice that that's a leg that is missing. The ladder is what is your hypotenuse. So because a leg is missing, we're going to end up subtracting. So when I solve this problem out, from here on out, this is stuff you should know from past weeks. We're going to do the hypotenuse squared minus the legs squared. So 10 squared minus 6 squared. 10 squared, remember, is just 10 times 10. So this is 100. 6 squared is 6 times 6, which is 36. When I subtract those two things, 100 minus 36, I get 64. And then my last step when solving the Pythagorean theorem is to take the square root. So I'm going to take the square root of 64, and I get that missing side to be 8. So A equals 8. So on my picture, I'm going to go ahead and put an 8 here. That's what that's representing. Now that I've solved that, let's go back to our problem and read what it's actually asking. It says, how far above the ground does the ladder touch the roof? Well, we just answered that, right? The ladder reaches up 8 feet to the roof. Okay, so that distance from the ground up to the roof, it is 8 feet tall. Okay, so that's that first one. The second one is Tom afraid of the height? Okay, so it's 8 feet high. Is Tom going to be able to make the repairs himself? If you go back to the problem, read that very first line. It says Tom is afraid of heights above 9 feet. So he's fine. He can do this himself. He's not afraid of this. So I would say Tom is not afraid because it is less than 9 feet tall. Okay, so we have used our answer here to answer both of those questions. Okay, so your final answers are those two red sentences. So that the ladder reaches up 8 feet to the roof, and that Tom is not afraid of this situation because it is less than 9 feet tall. Okay, so remember when you're solving these word problems, you're going to read the question and underline or highlight the important information, draw your picture, making sure to make a right triangle out of it. You're going to label your picture with the two sides that you know, and that will allow you to figure out if you're solving for a leg or hypotenuse. From then on out, you're able to solve it just like we always do. A squared plus B squared equals C squared. And when you get your answer, you then just need to look back at the problem and figure out what exactly is it asking you. Okay, if we go to slide 4, here's our second example. Okay, so once again, let's read our question. Let's highlight the important information. So there is a large park with a pond in the middle of it. To get to the other corner of the park, Maria walks 3 kilometers west and 4 kilometers south. The question that they are asking us is calculate how far the distance would be if she could have walked diagonally across the pond. Okay, so the situation we have going on is Maria's crossing the park, and she's having to walk around this pond. So how much quicker, how much shorter would it be if she could just walk across the water? Whenever you have these directional type problems, the first thing I always do is I kind of put the compass on my page. Okay, so on my page, I'm going to put north at the top, east on this side, south at the bottom, and west on the other side. The way I remember this and was taught in school is if you go like a clock, it should go never eat soggy waffles. So that's kind of a way that you can remember where those directions go. I'll go ahead and just start in the middle of my compass. Here's Maria. So here's going to be her starting point. Suppose she's already in the park. Here is Maria. That's her starting point there. And you will see that the problem says she walks 3 kilometers west. So I'm going to do an arrow towards west. I'm going to label that 3 kilometers. And then she goes 4 kilometers south. Okay, so then she goes straight down south. So 4 kilometers. So now I see where my problem is. I can kind of finish drawing in my problem. So here's where the pond would be, right? The pond is in the middle, which she's walking around. So here's the pond. And our question is, how far would the distance be? Is if she didn't have to walk around it, what if she could go straight through the pond? What if she could walk on water? Okay, so what is that distance? So you should see that we have this triangle set up. Here's your right angle up here. So that means we're going to be solving for C, our hypotenuse. Anytime you see the word diagonal, you should think in your mind, I'm probably going to have the hypotenuse. Okay, so this is our situation. Maria starts at one corner. She walks around the pond by going west and then south. And our question is, what would the distance be if she could just go straight across the pond instead? Okay, to solve this problem, we're going to go ahead and set it up. Because we're solving for the hypotenuse, we're going to be adding. So remember, a squared plus b squared. So 3 squared plus 4 squared. Going to simplify, so 3 times 3 is 9. 4 times 4 is 16. I'm going to add those two together, so 9 plus 16 equals 25. Remember, your last step in solving is to take the square root. So when I take the square root, I get c equals 5. Okay, so let's put this back in terms of the question. It says, how far is the distance if she could walk diagonally across the pond? Okay, so I'm going to answer that the distance would be 5, and then let's look at our units, kilometers. So the distance would be 5 kilometers. Make sure you're using the same units that they use in the problem. So if they're talking about kilometers, we don't want our answer to be in miles or inches or something else. So once again, we read the problem, we underlined the important information. When we drew the picture, we knew we wanted a right triangle. We saw that we were solving for the hypotenuse, so we solved. And then the final step is you're taking that answer and you're putting it back in terms of the question. So we answered that the distance would be 5 kilometers. And that is how you are going to solve word problems using the Pythagorean theorem.